Our next method of solving a quadratic equation is going to be completing the square. And honestly, this one is not my favorite, and I avoid it if I can, but it's something that's going to be really important to us as we go through conics, which will, I think, be on our next unit. Okay, so completing the square, there's a 5-step process that I'm going to lead you through or remind you of, hopefully. Step number one, the first thing you want to do is move the c to the other side of the equation. Typically, we want everything on one side of the equation and we want it to equal 0, but when we're completing the square, we want to get that c, that constant, on the other side. So it's not going to equal 0 anymore. It's going to equal whatever c is moved over. Okay, so that's step one. Step two, if there is an a in your equation, you want to divide it out. We can't complete a square when there's a coefficient in front of our x squared. That's our a, right? So we will have to divide that out of the equation. So hopefully you can see that if we have some odd numbers or something that's not divisible by a, we're going to get some icky fractions in these problems, which is one of the reasons why I'm not a big fan of completing the square. And actually, these two steps you can do in either order. It doesn't matter which one you do first, as long as you do both before you move through the next steps. Okay, so C has been moved over, A has been divided out. We're going to take half of B, so we're going to divide B by 2, and we're going to square it. And we're actually going to add that to both sides of our equation. Okay, so that B, that the number in front of our x, our coefficient of x, take half of that, square it, and add that to both sides of our equation. We're doing that because we're creating an expression on the left side that then will factor. And not only does this left side factor, but it factors as a quantity squared. It's called a perfect square trinomial. Okay, so we're going to see that something squared now equals our number. And then it's really just like the previous lesson in which we use square roots to solve. Okay, so then it's just the solving process. So we'll square root both sides and then we'll solve for x. Oops, comma. Okay, so C gets moved over. Divide out your A in any order. Half of b squared is added to both sides. Factor that left side. It should be something squared. Then we will just do our solving. So we'll square root both sides and then just continue the solving for x process. Okay, so that's how we will complete our square. So let's go ahead and try a couple. First one, I've got x squared minus 10x plus 4 equals 0. So I'm going to go ahead and take that plus 4, that c, and move it to the right side of the equation. So x squared minus 10x, I'm going to leave myself a spot because I know that I'm going to be putting a new number in there. So I always leave myself that space so I don't have to rewrite it. Now, if that was a plus 4, then I'm subtracting 4, so it now equals negative 4. Okay, there is no a to divide out, so I don't have to worry about that step 2. So I'm ready to go ahead and figure out what it is that I will be adding to both sides of my equation. So if b is negative 10, I'll take negative 10 over 2, and I'm going to square it. And that's what I'm going to fill in as my new value of c. So let's see, negative 10 divided by 2 is negative 5. Negative 5 squared is a positive 25. So I'm going to add a 25 to the left side. But hopefully you know when we're solving equations or whenever we're working with equations, whatever I do to one side, I must also do to the other, right? So plus 25 and plus 25 get added to both sides. Now we're going to factor that left side. But again, this thing should factor as something squared. So it should be the same number that multiplied with itself makes 25 and added with itself makes negative 10. And hopefully you can think, hey, that's negative 5. So I'm going to factor this as x minus 5. So we could write this as x minus 5, x minus 5, right? The negative 5 squared is the 25, and the negative 5 plus the negative 5 is the negative 10. But because it's the same factor twice, I get to write that as x minus 5 squared, and then equals the right side, which is 21. And now we're ready to finish the solving process. So we'll square root both sides of our equation. The square root will cancel out our square. So x minus 5. Now, if 21 was something we could square root or we could simplify, then I would expect you to do that. I'm thinking that 21 is just 7 times 3, and I'm not going to be able to simplify that at all. So the only thing I want to do to that square root of 21 is make sure I get my plus or minus in there. Okay, remember every quadratic equation will have two solutions, and that's where those two solutions come out, is with that plus or minus. So now I have x minus 5 equals plus or minus square root 21. And then to finish solving, I will add 5. Now typically, the notation is putting that real number, or that, I guess, rational number in front, and then I have my plus or minus square root 21 at the end. If you want to write that as plus or minus square root 21 plus 5, that's obviously equivalent. It's just not really the notation that's accepted. So same thing, I would rather you keep that whole number out front and then the plus or minus the radical. Okay, so there are our two solutions for x in this equation. All right, let's try one more. Again, I've got an equation. I know I need to move the c over, so I'm going to go ahead and add my 9. I'm going to get rid of that. So 2x squared plus 8x equals 9. But this guy has an a. There's a 2 hanging in the front that I cannot complete the square with. So we're going to divide out that 2. So we are really dividing this whole equation by 2. And this is legal as long as I do it to every single term in the equation. Okay, so we're now just going to make this x squared plus 4x. Here's where I'm going to leave my space to fill in, equals, I'm going to leave that as 9 halves. If you want to go decimals, that's fine. I just like using fractions better. This isn't a bad decimal, which is fine, but I just prefer my fractions. Okay, so now we are ready for the b over 2 step. And we're going to ignore the phone. So b over 2 squared. Oh, I forgot to fill in my b. b is 4. So 4 over 2 squared. 4 over 2 is 2. 2 squared makes 4. So I now want to add 4 to both sides. Okay, and now this left side is ready to factor. So x squared plus 4x plus 4 factors into x plus 2 and x plus 2. So I'm going to make this x plus 2 squared. The right side of the equation, oh, this is a good fraction review. If I want to add 9 halves and 4, then I need common denominators. So I'm thinking my common denominator is 2, or halves, which means I have 9 halves plus 8 halves. So 17 halves. Okay, and then we can finish solving. So we'll square root both sides. Look at that fun fraction in the square root. So x plus 2 equals, get my plus or minus. Now, I think we saw this in our last, solving method, is that this is not an acceptable way of writing a fraction or of writing a number inside a radical. So I'm going to split up my radical, make it square root of 17 and square root of 2, and then I'm going to rationalize it. So I'm going to multiply both numerator and denominator by that denominator, which leaves me square root 34 over 2. Okay, so that's what is on my right side there, square root of 34 over 2. And now I can finish solving for x by getting rid of the plus 2. So I'm going to subtract 2 from both sides, but I'm going to leave that negative 2 out front. So negative 2 plus or minus square root 34 over 2. All right, so there we have 2 examples of completing our square. Okay, again, not my favorite method. I don't typically choose it when I have an option, but it's going to be really important to remember how to do when we work on our conics.